Welcome back. If you joined me for my previous video, you'll know that I recently split up a whole bunch of images uh, with ChaiNNer in order to sort of separate them out from their grids. But as I mentioned in that video, since they come straight from the AI, they're not quite ready to be used as is. I'm going to want to try to face fix them first. It will hopefully improve the image quality of some of those faces. And so we're going to use another iterator, and I'm going to use the Upscale face node, and you'll notice here that it has some different parameters than we've seen before. It has the model, the input image, which is we're familiar with, upscaled background, which is optional, and we won't worry about that for now, and output scale. I don't want these images to be huge in file size, since they're tokens for use with virtual tabletops, and so large file sizes can cause issues. So I'm actually going to set that output scale to 1. We just want to fix the faces. We don't necessarily want to change anything about them. And then I'm going to set up a load model node. And I'm going to do this outside the iterator because that way if I have multiple iterators at some point down the road, they're not going to all load into memory. And you'll see that once I add this in, it's going to hit my RAM and VRAM. So I'm going to go to ChaiNNer. I'm going to grab GFPGAN version 1.4. which is the face fix we use, and drag that here. And we're going to ignore the model directory and model name, not important for our use case. I'm going to drag this image here. I'm going to select from the folder my commoners from the previous video. And now we have a slightly different set of needs. One thing that's worth noting is that we have we're performing an operation that changes the image itself. And I don't necessarily want to keep only the changed images because there might be a reason why I would want the original. Sometimes GFPGAN doesn't work very well with certain styles and it can actually make errors. So I'm actually going to save the image twice in 2 separate output folders. And then I'm going to want the text append model and switch the separator to space. And these are male commoners, so I'll set that to be that. And I'm going to want to number them so that they show up nice. But I don't want to just set that number here because it won't iterate and they'll start overwriting each other. What I actually want is this math node. I'm going to grab this overall index and drag that into operand A, put operand B to 1, and then drag this result here. And that will basically start at 1. Normally it would start at 0 because the first operand is 0. And it will basically name each output image as male commoner 1, 2, 3, 4, so on and so forth. And we're going to drag that to the image name for both of those. Normally you would not want to do that because they would overwrite each other, but we're going to be setting these to 2 separate folders. And so I'm going to go to where I save my tokens. Make a new folder for commoners. I'm just going to get singular to match case. And then set a subfolder in here called fixed to indicate that they've been fixed with GFPGAN. You could set this to the subdirectory path. I'm not going to do that. I'm going to be lazy and just select this folder. And you'll see that this is in the last folder since it didn't have anywhere it was pointing. Set that to onFixed. It's up in the new window so you can see it in a second. And then we're going to run all of those. And you'll see that this will take a little bit longer than last time because JPGAN is a pretty transformative process. It runs per image file, and there's 80 of them. So it will take about a second and a half on my machine. Your system might run faster or slower, depending on your GPU. I have 8 gigabytes of VRAM 3080 mobile card, so it's pretty fast, but not very good on VRAM. In theory, if you had enough VRAM, you could run these in parallel. I don't know if ChaiNNer is happy to do that. I would not recommend doing it because you might introduce instability, but there's no theoretical reason why you couldn't. And then these will, once they process, they'll simply output to this folder here. And you can see they're already coming through. you can see these are the unfixed images. They've just been renamed. If we go over to fixed images, you'll see that GPGAD has run. And sometimes the differences will be pretty limited. Sometimes the differences will be pretty notable. But you'll see that it does some work on fixing faces so that maybe noses are a little more defined, hair might be a little neater, so on and so forth. But that brings us to the end of this tutorial video. If you have any other questions about this, feel free to let me know in the comments. Please feel free to leave a like or subscribe if this is interesting. I plan on doing more videos on AI, ChaiNNer, upscaling, stuff like that. And if you'd like to support me, I have the link to coffee in my description for the video. I hope you have a great rest of your day, and I'll see you soon.